Hello everyone and welcome to I'm your data scientist.com. I thought to record another video on K nearest neighbor algorithm, KNN cluster. So today I'm looking at a data set which is you can collect from here. So the data set's looking at a cancer weight time between 62 days. Let's see what we can do with this data set, if we can arrive at a conclusion or not, some sort of clustering. So let's clear the memory and set path, then assign the data. And if you were to look at the data, data itself has got about more than 1,000 observations, and it's got 6 variables. It's got 2 character string variables. So one's called treatment months, one's called tumor site. So cancer tumor within our body. So for example, it could be breast cancer, gynec cancers, hematological cancer, head, neck, so on and so forth. So first thing I wanted to do was rename some of the columns. So for example, it says like X dot treated within 62. So when I looked at the actual data set, it was actually a percentage treated within 62 days. So I'll just rename that. The way you rename is you say column, then say the actual data set, which is this one here, and you call all the columns in sequential order. I'm calling that, and I'm also assigning cancer 1 as the cancer. So I'm creating 2 separate data sets using same data. Later on I will be explaining why that is. And now if you were to look at the structure, you'll see it's got correct name, percentage treated with 62 days. Then I liked the library deployer because I want only these 3 tumor site cancer. When I looked at plotted the graph, I could see these are the 3 highest. When I plot histogram, I saw these 3 were the most frequent one and most urgent one. So I thought to do just 3 tumor site and do a KNN rather than doing all, I think about 13 of them cancer site on our body. Let's look at the same. And if you were to look at now, I think before the observation was something like 1,000 plus. Now it's something like 967. It's the same. Then if I was to remove some non NA columns or the cells, then if I was to again and table, so it gives you all the tumor sites which is in our body, how many numbers of records or observation falls within these 3 different tumor sites. So now I have omitted some of the NA from that data set. This is the percentage of cancer data set. So again, I said I'll be choosing only 3 cancer site in our body. So one is breast cancer, hematological cancer, and the skin cancer. I think hematological cancer is I think related to blood cancer. So it's very very important, as in terms of treating them. So you need urgent care when somebody detects hematological cancer. So within our data sets, we've got 33% of hematological cancer, about 34% breast, and 34% again skin cancer. So if I was to do summary of this, so you can see the minimum is within no treated within 62 days, minimum is 1, and maximum is about 97 observations. So about it's quite a lot, I think. And again, no treated with treated over 62 days. So there's no one, as it says, minimum is a 0. So kind of everyone's treated. And let's look at summary of yeah, so there's no normalization available, because I wanted to normalize this data before applying the KNN cluster, but it doesn't work. But I will apply with other algorithm, not sorry other algorithm, but other techniques. So let's look at. So we know we've got about 317 observations. So just to look at something like. So remember we had before about 1,100 something plus observations. Then we've removed, we've only extracted 3 types of tumor sites. So that left us with about 317 observations. Then what I would do is I would do 70% of that is about 221 dataset observations, and but if you were to work out 30% for test is about just about 95%. Sorry, 95 rows or observation of 317 observations. So I'm saying, give me from first record to 221, 22, which is this one. Call that as a training data set, cancer training, and the other one is from next record, which is 223 up till 317. So I'll just call it cancer rather than cancer and I'll create labels with the same, and I'll call it class. I'll call a library called class, just to make, if you want to make sure if there are unique, what are the unique cancer or tumor sites, which is breast cancer, hematological cancer, and skin cancer. And now this is where we apply our KNN method. So not sure why this is giving me error. I think I knew why this was giving some errors. I think within the data set we had some blanks or NA, so I had to come and remove here and then go back to our code, which is somewhere here. Then apply training, then create labels, call library called class, then the apply z score, and apply the same thing with the training data set. Then apply this and say populate as cross tabular. So this is quite interesting. So now this is what KNN look like. So you must have heard something like confused metrics. So what is this tables cross tabular showing us is it's showing it has used about 95 observations. So if you were to add up all these, it will come up to 95, and we have correctly predicted about this is actual prediction, and this is um, prediction. So this is actual data set. So in column, and but in column it's the predicted values. How do you read? It's slightly challenging when you read when you're reading in three different categories. If you have a two, it would be more easier. But we will try. So we're saying we've correctly predicted there are 5 skin cancers. Then there's about 1 and about 31 in skin cancers predicted within our data sets, which are, you can see for breast cancer, we have predicted about 81% or 1% is 100% is like breast cancer data. About 26% are like we have exactly pinpointed them, and about same as with the hematology, about 1%, and we got about something like 3% are kind of type 2 error. Again here about skin cancer, we have kindly rightly predicted. But let's have a look at the plots. So if you have to plot, I need that GG plot 2, and first bring that in and zoom out. You'll see I've again plotted all the 13 different types of tumor sites. So you can see these greens and slightly darker green, and it's very towards the left. So I think it requires more urgent care, urgent attention. So let's see what are they. So it's related to hematological cancer. So as I said before, it's related to blood cancer, gynae cancer, probably stomach cancer or something. Then the breast cancer, breast cancer is here, and these pink ones are urological cancer, and this is brain cancer. So it's very hard to spot this brain cancer. Probably these are brain cancer, which needs urgent treatment. So that's why they're treated there and there. So within probably 10 days of span or something, they have to be scanned and identified whether they have actually brain cancer or not. So with this tutorial, I'll end here. It's very brief and very short tutorial. Please have a look at the other tutorial on KNN. My aim is to at least record at least a tutorial on a data science or machine learning tutorial, at least a week, once a week. This is Yogesh from IamYourDataScientist.com. Thank you very much for watching my video, and hope you enjoyed this video. Thank you very much. Thank you. Bye.